So let's look at 5b. It says find a Cartesian equation for the curve that contains a parameterized curve. Let's recall what this curve looked like. So this is number 5b. So if we're looking, that was that one. That was just, it looks like just a square root, I think. Just kidding. It was the parabola. And we're going from negative infinity to positive infinity. So it is just a parabola. And then it says, so find a Cartesian curve for the parameterized curve. So really, we're going to just look at that. And it takes a little bit of thinking. But really, remember, we're trying to eliminate t. We're eliminating the parameter. So we just want something with x's and y's. So I'm going to do operations on x's and y's until the t goes away. Or until I can replace stuff. And actually, this one will be very easy. 9t squared. So right now, I know that I have, this is like my base definition because it's the most simple. This is a little bit more complicated just because it has t squared. But look at this. It's very, very simple. Like, we're going to plug them into each other and see what happens. Well, actually, not see what happens. We know that t is the same thing as, oh wait, no, that's not true. Is that? It's 3t. 3t. There we go. That's better. We know that 3t is the same thing as x. Well, instead of writing 3t like this, I want to know what t is. So I'm going to solve for the parameter. That's a good thing to do. That's one way, especially when they're linear or sorry, non-trigonometric stuff. You can solve for t and then just plug it into both, and that's how you eliminate the parameter. You can, so for regular functions like this, for non-trig functions, you can just solve for t. I suppose in trig functions you can as well, but we use trig identities there. So here I'll solve for t. I could do it in either case, but I would lose stuff, I think, if I did it in this case, because I'd take the square root. Maybe. I don't know. I haven't thought about it all the way. So this is actually x over 3. So we solved for t, and now I'll take this and I'll plug it into y. So y equals 9 times, well, x over 3 squared. What happens? Well, this would be y equals 9 over x divided x squared, right? Because it goes to both of them. 9. That cancels out. Y equals x squared. We saw half of that graph in the calculator when we did it, but it is the whole thing because the parameter is not restricted. And there you go. That's eliminating the parameter. What were the other instructions? It said eliminate the parameter. What portion of the graph of the Cartesian equation is traced by the parameterized curve? In this case, it'd be all of it. In fact, it's kind of weird to think about the direction of it. I mean, t will count upwards from positive to negative, so it will go from left to right. In the answers that it shows, it only shows the left side of the graph, and it's saying that it's going up from left to right, but I don't agree with that. The B answer doesn't agree with the answers that I from the back of the book. The B answer agrees with what I was saying for part A and for part B, but the B answer doesn't even agree with its own A answer, so it makes me question it a little bit. But there you go, that's 5B.